please join me welcoming Prabal Banerjee from Evel. Prabal will discuss how cross-chain interoperability can deliver seamless amidst online user experience in Web3. So the stage is yours.
Hey everyone, I know today this is the last presentation, right? So I wouldn't want to keep you guys here for too long. I will try to wrap this up as short as possible, but at the same time, want you guys to go out feeling that there is some new paradigm that is getting built. And this is not just getting built by us, there is so many partners in the blockchain ecosystem who is looking towards the same vision. We are trying to make our contribution in that part. The title of the talk is essentially how we can have an Amazon-like experience in a cross-chain world. Now, what does it mean to have first Amazon-like experience, and what is the status quo in the cross-chain world is what we need to look at first. One thing that I think is non-debatable at this point in time is how the status quo is fragmented. You have your assets lying across multiple different chains. You have enough funds to do an action, but you cannot do it because of the lack of funds on that particular chain or on that particular asset class. And in this kind of a world, the user experience is completely suffering, right? And that has been a big point in the narrative play that has been going on, where monolithic chains are taking over in terms of user experiences. And rightly so, because as a user, I don't want to care about which chain I'm using, what is the security primitive, and so on and so forth. I just care about the best in class experience. We don't need to reaffirm our point here, but this is screenshots from L2Beat and such. You can see there are like 50s of L2s that is there listed, and many more growing, and we contributing to that. Bridges, there are many types of bridges, all having different types of security guarantees and security assumptions and multisigs and POAs and whatnot. And we don't have a very good feeling of how exactly the security model is changing beneath the feet of the user when they are doing cross-chain applications. Let's talk about bridges a bit. This is one style of bridging, but this is the most prevalent style of bridging that you will see today. Let's say you have two chains, Optimism and Arbitrum, and you can change this to any two different L2s. You basically lock your funds on one chain, go to the other chain, prove to that other guy that I really locked my asset on this chain. Based on the primitive that this guy is convinced of your statement, they will mint corresponding assets. This is only one part of the bridging. Suppose you have done your action here and you want to bridge it back. You essentially burn this and then again convince this guy that you have essentially burned all your assets on this one. This is a typical experience across L2s, across chains. But let's talk about a bit of Web2 experiences. You are going to Amazon. Amazon is, just think of any other marketplace that you have. Let's say they are trying to give you the best-in-class experience, but also the best-in-class product in terms of what a marketplace can provide. So here is your best marketplace. Think of anything. More often than not, they only specialize on being a marketplace. They don't handle payments. Amazon handles payments in some jurisdictions, but roughly speaking, generic nature of marketplaces is that they do not handle payments. But you cannot buy a product without doing payment, right? Can you buy any product on any marketplace without paying for it? Which means that payment is an essential part of that product, which it is not building, but it is doing so with something like a PayPal or a Stripe or a payment aggregator. Now you see that these payment aggregators, and you know all the familiar names in this space, they are doing an amazing job just doing one thing, which is aggregating payments. They are the middleman where you don't need to worry about what your credit card or debit card or what kind of card it is. It takes care to transfer depending on what kind of card do you have. So it can connect to a Visa or a MasterCard or an Amex or something which is very popular in your jurisdiction. But this is the guy which actually does the payment. Mind you that they do not hold funds. Visa doesn't hold funds for you, right? Your bank holds the fund, your card has an account balance, and so on and so forth. Then how come something like a Visa is able to accept the payment on behalf of you? This is because they actually make a call to the bank API. This is the familiar pattern. This is a promise resolve pattern that you see across the entire Web2 stack. None of the Web2 services today work without a promise and a resolution of promise. So you make all asynchronous calls all across Web2. When you actually think about it, the callback here is that Visa gets the affirmation from the bank. The bank says that yes, enough funds are there, or they can settle it with the user. The Visa gives that assertion to PayPal, PayPal gives the assertion to Amazon, and all of this happens in a seamless manner. You do not have to worry about whether you started with a Visa card or something. Amazon doesn't care, and it doesn't need to care. This is the experience that I'm talking about when I say Amazon-like. Now let's think of an ideal world. An ideal world where you do not know anything about blockchains. You do not know anything about chains. What should ideally happen is you need to have very specialized chains which are very good at doing something. That is because if you think of the product level stack, the architectural stack, you can make only trade-offs when you have specificity like instead of genericity. Genericity makes things bloated, right? And specificity is what brings more and more, user level experiences to the end user. And that is very clear, right? Today, think of Ethereum. Ethereum did a mind-boggling thing of bringing general like computation inside blockchains. They made general computation possible, and no wonder that they are the EVM is not the most optimal in terms of pricing transaction. You cannot do both things. You cannot have Turing completeness as well as no gas limits. That's just not possible. That is just beyond theory of computation. Basic college is what have taught us today. But L2s took it a notch up. They took things to, let's say, a centralized sequencer, which gives you some level of guarantees, but at the same time, now you can get user level experiences where an Arbitrum can offer a 250 millisecond block time. This is only possible because they are going for specificity in terms of how the architecture looks like. That same level of specificity needs to go into the virtual machine level, where you can think of one chain being very, very specific to just handling NFTs. It's the best ERC-721 chain that you have ever looked at. It has all the basic primitives and the precompiles needed to make ERC-721 as performant as possible. And think of another one which is a payment chain. So think of any ERC-20-like token, but it is the ledger of your choice which only tackles fungible tokens. In this kind of a world, what you would want is a trade needs to be placed on this NFT chain. This is your Amazon. Whereas your payment needs to be done on the payment chain. This is your PayPal or Visa or whatever equivalent. This is what handles your payment. This is where you keep your funds. This is your hot wallet. I'm not talking about a cold wallet. Let's say this is your hot wallet, and this is the user level application which you are trying to use. In this kind of a world, what we need to have is you need to give a cryptographic guarantee to the NFT chain that the payment has been done. That's how e-commerce scales, and that's how we need to scale blockchains. Think of the times when there's a huge surge in demand because there's a sale. Let's say there's a Black Friday sale or your typical local festival sale here. In that time, the marketplace scales. The payments don't. Payments know the kind of TPS that they can provide. Depending on which bank, the bank doesn't scale up its resources just because there is a sale happening. It's the marketplaces which scale because the payments, they take the similar cadence. Enough jargon and enough thoughts. Let's talk about how do we do it. This is where Avail Nexus comes in. We are trying to look at a world where you can seamlessly interact between two different chains, and this we think is a precursor to how chain abstraction works. Chain abstraction tries to abstract out, and that is definitely needed, no doubt about it. We are thinking of this as more like a primitive which enables abstracting of chains. What does it do? Basically, it is a permissionless verification hub. What it does is It takes multiple roll-up states, it computes the proof and aggregates them together, and then provides a single aggregated proof back to all the other custom chains. Think of it like I do not need to verify one chain with the other. I will talk a little bit about that probably here. You can see today this is what the interrupt today looks like. You have 4 different chains, you have hundreds of different connections. All the different connections are of different security primitives. You have a validator set driven, you have a light client driven, you have a proof of authority, you have a TEE. All of these wrapped tokens are very different. They are not the same. The guarantees are not the same. And that's why you need to create all the different kinds of user level interactions that you need to do today. You need to go to a bridge aggregator to be able to bridge your funds. You do not go to bridges even today. And what does it mean? It means that when you have one aggregated proof, and zero knowledge proofs gives you this enormous benefit where you can basically compress computations together, you do not need to verify individually chains. You just have to verify one aggregate proof. This aggregate proofs verifies that all the state transition functions across all the different chains worked actually correctly. That's what was defined in the state transition function itself. So EVM chains, they already have EVM. If you just agree that there are no new precompiles and such added, then that is a specific type of execution engine. And that means that all different execution engines are actually having the same state transition function, which we can verify. Just tell me when it's 5 minutes. But like, what do you actually need to verify a rollup? That is extremely important, because you can tell me like why Avail needs to do all of this. Why cannot I do it with any other play that is there in the market? And one thing which is very, very core to our philosophy is that of security, right? So we were thinking from the bottom up that what is the security of a rollup? What gives the rollup its security? So there are 2 main components. One is data availability and the second is execution. A rollup which cannot prove its execution is not even a rollup, right? Because then it's a pessimistic sovereign chain construction. When it talks about a rollup, it has to have verifiable execution. And that today typically is done through 2 methods. One is fraud proof, the one we known as optimistic chains, and the other is validity proofs or ZK rollups. So these are the 2 main types of L2 stacks that you see today. That is all fine, but if you do not have the transactional data or the state delta, you cannot reconstruct, which means that depending on what is your execution proof, you can either get stuck or you can get completely corrupted. In an optimistic chain, if the data is not available, no one can actually act as a watchtower. You can completely get censored of the data, which means that an attester can attest to arbitrary statements, which makes it completely insecure. In ZK rollups, it's much better. You cannot get safety failures because it's a ZK rollup. The soundness of the ZK proof allows that, but you can get stuck in terms of you know that you have funds, you know that the computation was done correctly, which is that no fund was compromised, but you just can't exit. That's what enables like having data published for any user to do is have arbitrary exits, and that is one of the core thesis of why rollups are secure. This is what we are envisioning. We are envisioning that different rollups all just talk to Nexus, and the Nexus acts as the source of truth for all these chains to each other. When I say source of truth, I do not mean that Nexus has again a different security primitive. What I mean is, how can I make this the most trust minimized construction that we can? So this is what we are thinking. We are thinking that there is this Nexus middleware which takes the state updates from all the different chains and then provides one single aggregated proof back to all the other chains. Which means that if I want to know the state of chain A, I just need to verify one aggregate state. Not only A, I get B to Z for free. I may or may not use it. That's on me because you have to make chains sovereign, right? I cannot impose interoperability. That is just breaching their sovereignty. But at the same time, there is no harm, there is no level of extra computation that they are paying because the aggregate proof is just the same. That's what constant size aggregate proofs are giving you today. Okay, sounds great, But what's the bottleneck? Why hasn't everyone done this already? Why haven't we done it already and showing a working demo? This is purely because all the different roll-up stacks use different kinds of proofs. Today, the proof side is also very, very fragmented. If you see a Polygon ZK VM has a different proof system than a ZK Sync, which has a different proof system than a StartNet, which has a different proof system than a Scroll. Where do I go? How can I make these roll-up proofs all the same? And this is where the adapters come into the picture. We are trying to provide a homogeneous interface across heterogeneous proof systems. This one is the trickiest bit, because now you need not need to worry about others' curves and what is most optimal, whether someone is working on a 32-bit field or a 64-bit field or a 56-bit field, whether integers are native to that construction or not. You do not need to worry about that, because all you need to worry about is, can I have a single verifier encoded as an adapter, which in turn makes all of this click together. In the end, this is what we want to look like. We want it to look like this, that it should look like much like the airplane ticket booking system or the Amazon experience that you have today. You want to buy an NFT? Yes, you go and reserve the NFT first. You do not need to reserve it yourself. The wallet takes care of it. It reserves the NFT. It then asks for Nexus for a proof of payment inclusion. Where the user makes the payment inclusion goes to Nexus, and it can be proved that the payment was done. What's better is you can also prove that the payment was not done. What cryptography gives you is both sides. You can prove, if it's a sound and complete kind of a environment, then you can not only prove that you had included a payment or you have done it, or you can also show a timeout. Today, most of the payments that you do not actually go through are actually timed out, right? Now, after you time out, how do you show that within the certain period of time, you actually did not pay out? That is why you can here give a payment of, like, a proof of inclusion, but you can also give a proof of non-inclusion. Those are the powers of cryptography, which will make it look like this, where you have both execution and data will be separate. There are n number of modular chains, all building with different types of stacks, and there are many, many other stacks which we have not talked about today. All of them posting proofs to Nexus, and the most basic thing is you can run a light client, your wallet can run a light client, your Raspberry Pi, your smartwatch can run a light client in order to verify Nexus, which means that you can also verify that all these different chains actually did their task correctly. Think of the enormous level of user experience improvement and the user guarantee improvement that you can give. Today, either you ping an RPC, which is a centralized service, and you rely that whatever account balance that they give to you is correct, or you run a complete full node, none of which are possible in user level devices. When you go into a light client mode, when you have the power of verifiability through validity proofs and data availability sampling, they two together make it all possible to run inside a light client. You neither need to download the entire data, that's data availability sampling, nor do you need to rerun all the computation, that's what validity proofs gives you. To take it all back, this was the Amazon Live experience, that's what it looked like. Hopefully this is what we can bring here, where there's an OpenSea, you can go and check out, and this is not far away, right? Many of the existing top of the line dApps are starting to becoming their own app chains. So I'm not talking of a world which has never been seen before, it has already been promised. People are going to build their own application specific. Once you reach a significant level of scale, you have to provide your users with better guarantees, and that can only be provided with application level rollups. Once you have application level rollups, then this kind of experience has to be there. Otherwise, asynchronous communication cannot work out. All of this inside the same chain cannot scale up. And if there is no real trust minimization guarantee between, then you will face the Cosmos-like conundrum where individually they are all secure, they are also connected, but they don't talk to each other. That's it. Thank you. Happy to answer questions.
Thank you very much, Prabal from Eva. Thank you very much for sharing the insights. And if he's still around, feel free to connect and discuss with him as well. And this is the final session for this Buddha Stage event, and that wraps up our Proton Layers conference. So thank you so much, everyone, for being with us today, and our sponsor as well for making this possible. And have a good trip and enjoy Bangkok as much as you can before the wrap up of DevCon 7. So have a good trip. Thank you very much. ขอบคุณค่ะ